Hi friends, so welcome to this video, and I wanted to talk about server sent events in here. And the use case arise because as my side project I'm building a game, and in that I was building a leaderboard, uh, and I want to keep it like live leaderboard. So the use case here is in this on the server end, I'm calculating like who is on the, like I'm calculating the values for the leaderboard, like the score of each player, and then every player can go and look into that leaderboard, but they cannot action on, they don't need to any send any request. So it's like one way connection from server to client. And I felt like WebSockets, opening another WebSocket connection just to get that like information and those kind of things may not be the best solution. So I thought like maybe server sent events is the right thing to do, and it turned out so that was a use case of server sent events to send things like notifications or update things on the client which don't require any client input, or like they don't need to sync different clients altogether. So not really a WebSocket use case. So let's take a look into it. So to start with, like the normal HTTP, just a bit of background. The way HTTP works is we have a client and we have a server, and client sends a request to the server, and in response server responds back with the data or acknowledgement or whatever. So that's how it works. And in this case, always the connection starts from the client to the server, and the server responds. It's unidirectional. It does never goes from server to client. Like if server needs to update the client, it cannot do that. And use cases as we use it, like we use it for REST, so to react to customer actions, like if they need to like a counter or something on the server, if the values are maintained, status maintained, we send HTTP request as a REST endpoint, or get data from the server or update the data on the server. So we do that with HTTP. But when a use case comes that we need to update the client uh, because of a change in the server, how do we do that? So enter server side events. So server side events, the action happens from server to client. So the way it happens is in the similar way as with HTTP, the server sends a request, so it's a HTTP request, and then the client sends HTTP request, and the server opens a response stream. So it opens a stream, and then as soon as it starts keeping data on the stream, these clients get updated. So the use case here is like if you want notifications from the server and update data in real time, like dashboards or something like stock market data, so we can use server sent events for that. There's one thing to keep in mind, that this response stream connection is connected to a server. Let's say if this server goes down, what do we do? In that case, we have to establish the connection again. So we would get like a close event or something on the client, and we would establish the connection again to a new server in our service. So that's one overhead we have to do. Whereas since HTTP connection here, these are stateless, like the server doesn't really matter like which server you connect to. So it's very easy, like if this server goes down, we just send a next request and it gets redirected to the other server. So that's server sent events theory part. Let's look into code example. So what I have here is a very simplistic demo of server sent events. It's a simple Node.js and React app. So Node.js in the backend, React in front end. The way it works is we have got these 5 accounts, and you can have different kind of actions, like multiple users doing different kind of actions. And I want this notification feed to be populated with what kind of actions happen for one user if a separate user takes it. So to simulate that, let's go to our backend. I'll cover the code later, but for now, let's add a set interval. So every 3 seconds we'll send a notification that something changed. So mimicking like how the backend would work, this would work like somebody actually did any action on the account. So our server will get the request, and then it will update the server state, which should send the event to all the clients that require it with the notification, then they show it. So in this case, as you can see, the notification starts coming in. So every 3 seconds we get the notification without any change in the UI. So let's go back and look at the example of how it works. So let me just refresh and come back here. I can keep it running, but yeah. So what I have here is a very simple server running on localhost, and the thing to keep in mind is this notification endpoint. So our app has to call this first to actually open up the stream, so that we can actually add the response to it, and front end can receive it. And I'll cover the front end part where we call it. So what it does is, notification part, we set the some response header. So this one is really important, like event stream. So this is event stream, so we need to set that and keep alive. So these two are there. Flush headers is there's a optimization, like the headers get set when the value is set, but in this case the value will be returned later. So we do flush headers to remove that optimization and make this work. The next one is clients.push response. So I'm kind of getting this client's object out of the scope from this particular function, so that we can use it outside and add response to it, or add, use this response object to actually send the events to front end. So that's the first part. The second part, let's look at this auto interval part. So what I do is, this is just like account Metaflow random, like picking one account. So it will pick notification from one of these accounts, and then I build the notification. So it's just a simple JSON object. Again, I pick one of the notification type and build the object, which our front end knows what will, and then call broadcast. This is an important one, what broadcast does. So as you can see, broadcast does, it sets the data as JSON.certified notification. So it is this JSON object which gets returned from build notification. It runs that and it writes it to the response stream. And when it writes it, the client gets it and then actions on it. So let's look at the client code also, how that works. So this is a very simple React app. So as you can see in this particular component, app component, when I come, the first thing I do is, in use effect, I call the event source object. So it's supported by almost all the major browsers, I would say, or all the browsers out there. So you just create an object for it, and then see what we do is on open. So if the on open gets called, then we actually set the set connected state true or false. So if you see the connected, we have a green button on top of it. So I show that if it's connected or disconnected. We can actually see an example. If I go and close my server, we are disconnected now. So it responds like it gets the event like disconnected. So now if I start it again, it should connect it. It's connected again. So that all is handled by the browser. We don't need to worry about it. We just need an on event, on open and on error, and on close. Yeah. So now the next one is, we have got this on message. So what this on message does is, we have got notification. So on message will get the event, and we extract the data from it with the one which you put on the stream, and then we push it to our set notification state here, and then we display the notifications. So yeah, that's how it works. Like on the front end, you use the event source object. Regarding authentication and stuff, like by default our browsers would add cookies to it. So if you're using session ID in cookies, you can push it there. You cannot set custom headers here. If you're using token, just add it as a get. So that's one security bit, but for me, I'm using session token, so it's in the cookies, so that works for me. Yeah, I think that's what I wanted to cover about server sent events. Please let me know in the comments if you have any questions, or if there's any other topic you want me to cover. Thank you.